All right, so welcome back, and this is called binary tree level order traversal. So this is a medium level question, and it's number 102 here. So let's take a crack at it. So essentially what we want to do for this is we're going to traverse it in level order, which is essentially breadth first search order. And so we're doing it level by level. So we want to look at all the nodes in the first, or I guess level 0 here at the root. And then we want to look at them at the first level here, 9 and 20. And then we want to look at them at 15 and 7, the second, or in this case, third, level. So, and what we want to output is essentially a list of lists. And so that list of lists here, you can see the kind of nested arrays inside, are just the integer values of these nodes. Okay, so let's take a crack at it. So what we're going to do is first we want to instantiate that list of lists. So we'll do that. So I'll just copy it over here to make it quicker. And we'll just call this output. And we'll just instantiate it. And so just like a lot of these problems, the first thing that we're going to want to do is check for that base case of, okay, does this contain nothing? Like, does this root, is it just null? Do we have no tree here? So let's go ahead and do that. So if our root is null, let's just return our empty list of lists here. Okay, so after that, we know that beyond this point, we actually have a tree to work with. And so then just let me think here. We're going to create our queue. And so we're going to make use of a queue, and we'll just call this, well, actually it's going to be a linked list that we can implement as a queue just using the offer and poll method. So, and it's going to be of type integer. No, it's of type tree node. And so this is what we're going to be using to kind of add and remove from our queue to determine the order of which that we're evaluating these nodes. And so let's just call this queue. And so the first thing that we're going to do is we're going to enqueue to our queue the root. And so now we know that our queue has at least one value, and it's our root node. So just so that we fill this in here, at the end we're just going to return this output. And so the rest of the logic is going to be within this while loop. And we're going to keep looping while our queue has something inside of it. So while this is not empty. All right, so now what we're going to do, just let me think for a second. We're going to grab that value. So we can do a queue.poll. We're going to grab the tree node from our queue. Or wait, no. What we want to actually do is get our length. So we want to determine how many nodes are in this current level. And so in this base case with the root, we're just going to have one node in this first level. So we'll just call this level, and it's going to be equal to our queue dot size. And so now what we're going to do is we're going to create a for loop starting at 0, and it's going to go until, I'll just set this as the length. And so while I is less than our length, and we're just iterating through the values in our queue. So, and I++. And so what we'll first do is get our current tree node. We'll just call this node. And it'll be the from our queue. And so this is just like we're doing a dequeue. It's just the linked list equivalent of doing it's a hard word to say, so the dequeue function. And so with that, what we can do is we're going to add that value to a working list. So this nested list here, we're going to create outside of our for loop. And let's just call this level list. And so this is iterating through the entire tree. And so this is going level by level. And so we iterate here all of the levels in the tree. And so this is what's actually each individual level will execute within this for loop. So we'll call this level list, and we'll just create it here. And so this is going to hold all of the node values for that current level. And so then here, we're just going to add the value of that current node. And it's node.val, just when we look at this tree node class that they provide us. And so what you would then expect is that at the end of this level, we're simply going to add this level to our output list here. And that's why it's a nested list of lists. It's going to add that level list to our kind of working list for the entirety of the tree. Okay, and so the next thing that we want to do is we're going to want to grab the children, the left and right children, since it's a binary tree, that come after this current level. And so what that looks like is we just check if our current working node's left child isn't null. So if this isn't null, we're just going to want to add that to our queue. And we're going to do the exact same thing for our right node. And if this doesn't make sense, I'll explain in a sec why this works. But let's just try running it, just see if there's any errors. Oh, success, so that's great. But let's take a peek at it. I thought I would have at least 1 or 2 errors with it, so I guess I'm improving. And so what this looks like is the reason why we can add these left and right nodes within this for loop is we know that although we're adding to the same queue that we're kind of dequeuing from or pulling from, they're never going to get executed within this for loop. And so these are the nodes for the next level. So they're not even part of this level. So say this is iterating on level 1. These are for level 2. And so although we're adding this, it might seem like it's going to be like an infinite loop where we're constantly removing one node but adding 2 nodes. What's really happening is because we have this length, while it's less than the length, it's going to have a cutoff before you ever get to the next level's nodes, because we know how many nodes are in this level based on this queue.size. So that's really the caveat that I didn't understand initially. And once I got that, it's like, okay, this isn't going to loop infinitely by removing 1 and adding 2. This is really just, it's going to stop once it hits the current level size, and then it'll iterate on what we added in this during this level the next iteration. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks.